Hello and welcome to day 14 of Advent of Code 2024. This puzzle is called Restroom Redoubt. So one of the historians needs to use the bathroom. Fortunately, you know there is a bathroom near an unvisited location on their lists, and so you're all quickly teleported directly to the lobby of Easter Bunny headquarters. Unfortunately, the Easter Bunny headquarters seems to have improved bathroom security again after your last visit. So that last visit was day 2 of 2016. So this kind of tells you a little bit. We have seen it before. We have seen it with the amphipods from I think it was 2021 or 2020. One day 23 or something. So that kind of gives it away that this year's Advent of Code will have a kind of a tribute to previous years' puzzles in some sense. So the historians need to go safely to the bathroom. So you need to wait to predict, because there are robots swarming outside these bathrooms, and they need a way to get through them. So you make a list, which is your puzzle inputs, and it looks like this. So we have the positions, x and y coordinates, and the velocities, x and y coordinates. And the robot will kind of teleport by these values every second. So in this for this row, maybe it's this robot will kind of go 3 plus 3 on the x-axis and minus 3 on the y-axis each second. And this map here is kind of double-ended in both directions, so that when they go outside the map on this end, they will end up down here, and when they go outside the map on the right, they will end up on the left, and vice versa. So it kind of wraps around in all directions. So here we see that there is a state after these seconds, and in the end, what you need to do here is actually split that map up in 4 quadrants and count how many robots there is in each of these quadrants, and the safety factor will be the product of those quadrants counts of robots. And what you can see here is also that there can be 2 robots in the same location, or there can be multiple robots in the same location. So there is not so they can kind of stand over each other. Yeah. So now I'm going to show you actually when I solved this morning, but I also realized after I did that recording that I didn't actually show you the part 2 of this problem in the right way. So I will actually do, because what I did was, it took me about 30-40 minutes or something to get the answer correct on part 2, so I just actually paused the video and paused the recording while I did still a lot of changes. Then I actually didn't actually remember to turn it on again until I actually found the answer. So that's the way I didn't actually show you how I came about that answer. So I think that deserves a little bit of deep dive, because this part 2 is a little bit special. But let's get back to that after this next section of this video. So I will do the part 2 deep dive after this. So let's go directly to the solving of this puzzle. Okay, so let's go to the solving of this puzzle. So this will obviously be where I read all these instructions and checking out the problem. It's basically how I do it. It just kind of goes, yeah, I kind of speeded this thing up a bit. So the first thing you always do when you solve these kind of problems is that you will have a reading of the input, parsing that input. So now what I'm thinking here is that the input should be kind of two lists, one for the positions and one for the velocities. And the velocities, yeah, so it will be both these positions. Yeah, so now I'm just kind of thinking about how do we split this. I mean, this is obviously always going to be some kind of issue when doing this kind of when we are actually going to check how to parse the input. So now I'm thinking let's split it by the comma, then parse the integers out of that. Do the same thing for the velocities. Yeah, then we just add them to the list, and that basically now we actually have our parsing of the input done. So now we're actually defining the move. I decided to do a method for moving the robots, and that method should obviously be called one time for each second. So that's why I have the for loop for the 100 seconds there. So now I will kind of just do the increasing. So I'm increasing the x position by the velocity x position. Then I add a code to handle the wrapping of the map. Then it will be basically the same thing with the y position. The y position we will check obviously against the height. Yeah. So now we will just call that method. Need to define those width and height variables as well. So now we need to split those positions into quadrants. So define those quadrant counter variables that I use. So like if the x position is less than the width divided by 2, then and if the y position is less than the height divided by 2, then we are in the first quadrant. So if the y position is greater than the height divided by 2, then we're in the second quadrant. Then if the x position is greater than the width divided by 2, and if the positions y is less than the height divided by 2, we're in the third quadrant, and if the y position is greater than the height divided by 2, we're in the fourth quadrant. So, and as I speeded this video up, obviously I didn't do it that fast, but I mean, it's not that, the part one of this problem is not that complicated actually. It's just basically to code it up. It was pretty clear for me from the beginning how to solve this. Uh, yeah, so now I will just kind of take out the product of those counts from each of the quadrants. That will be the safety factor that we should have for our part 1 answer. So now it's just a matter of running it and posting the answer on the website. So we will take this value here. We'll check. Hopefully this is the correct answer, and yeah, it is correct. It was the correct answer. Now you saw that I have an issue with my recording software that it doesn't actually record the entire screen of the web browser for some reason, and I cannot. So this is what I'm doing here is actually trying to position the browser within that recording area so that I can actually show the bottom of the web browser. And yeah, so I'm just fiddling with that a bit here. Yeah, I think this is the best I got. But I mean, so now I'm going to do the part 2 here. But the part 2, this is actually a little bit jumbled up because I had issues with this, so I didn't actually record the entire solving of this when I did it. So I need to. That's what I'm adding the deep dive that comes after this. I'm going to actually explain how I got to that result. But so because when I recorded this, I just actually paused the recording, and then I forgot to actually turn it on again, and that's why it kind of is a little bit of jumbled up. So yeah, you will see. So now in doing part 2, I decided to actually extract the part 1 solving code into a new method, so that the code will be a bit more manageable. And I just paste that in, and then we will just call the method, remove that code. So now we're at the spot where we can start coding up the part 2 code. So that will be within another method as well here. So yeah, so this method will be called kind of get seconds to form the bot Christmas tree. It will take the same input as the part 1 method. So now I kind of got to the point where how should we do this? I mean, this was not very clear, and the description on the website didn't actually give me a good way to find that out. So my first thought here was kind of having some kind of state hash set where I should save the positions of the the robots and check if those positions kind of reappeared, and that could be some kind of thing that could solve the cycles. So now we are actually now it will be kind of a jump here soon. Yeah. So now we're already at another position in this video, and then there is a jump again, because now I actually tried a bunch of times to do this, and I will actually no, maybe we haven't come now. I think now there will be kind of a new. Yeah, so this is actually cut. You don't see it actually because there's kind of a good way, but you don't actually get the explanation for this. So So I mean, you only see that now we have solved. No, okay. This was one of the tries I did, but okay. So now I think the cutting was after this somewhere, because now the so this is actually after, before I started my long testing run, because what I realized now that I need to actually reset all the positions and the positions of the robots before actually calling this part 2 method. So that's what's going to happen now. So now we have the correct answer. Okay, so this is the kind of a deep dive on the part 2 of this day 14. So uh, during the bathroom break, someone notices that these robots seem awfully similar to the ones built and used at the North Pole. If they are the same type of robots, they should have a hard-coded Easter egg. They will rarely, most of the robots should arrange themselves in a picture of a Christmas tree. So what is the fewest number of seconds that must elapse for the robots to display that Easter egg? Before I kind of show you my solution of this, I want to talk a little bit about this puzzle, because, and I don't think I'm alone alone at this, because there are several problems about this part 2, and the most obvious one is actually that we're going to look for a Christmas tree, but how do we define a Christmas tree? I mean, there is no actual explanation of this. It kind of I mean, it demands actually that you you display something. You have to kind of look through a drove of jumbled images of those robots' positions, and somewhere deep down inside that you will eventually find a Christmas tree image. But how does it look? You cannot actually validate that these robots' position will have formed a Christmas tree, because there is no kind of validation for it. They don't present that, well, when the robots display a Christmas tree, they would have these positions or something like that, or like some of them would have these positions, so that you can actually search for it in some way. So this actually I mean, I've also seen one other solution for this, which is not the one I used, but where they kind of used the safety factor calculation from part 1 and kind of made a loop, like made a loop. I think it was the width of the map multiplied by the height of the map times. So that's roughly something about something 10,000 times or something. So there are kind of the loop will simulate 10,000 something seconds, and they will calculate for each iteration. They will calculate the safety factor, and when and also keep a track of the lowest safety factor. And in the end, the lowest safety factor, when they found the lower factor, will also kind of save the second that was found. So the second the lowest safety factor was found could also be the answer for this. but that's not how I solved it. So okay, so let's just look at the code again. So here are my kind of code for this. I've actually added a little bit of new code here. So I have a kind of print function here to print out the robots. I've also added some, if you see all this code that I commented out, I will actually use this in this presentation here. So yeah, so the way I did it, it was actually pretty boring sitting watching all these positions, and I kind of guessed from the beginning that this would be a higher value. So I think I started around the 3,000 or 4,000 second or something, and I just kind of watched 500 seconds at a time or something. So I added a thread sleep in between, so that I wouldn't, so I had time to look at it while it displayed. Then I also had kind of clearing of the console in between those images, so that I could just look at them. And then at the 7,753rd second, I found my Christmas tree. But so I'm just going to show you a little bit how this kind of process would have looked like. But you can imagine that that I looked at a lot of jumbled images. So maybe maybe there is I mean, the other solution that I explained before might have been easier, and then that could have been solved only by code, so to speak. But that's not how I did it. So yeah, obviously there is no there might not be any correct way to do this, but yeah. So we will also do this right now. So if you run it now, you will see kind of a blurred image. So let's just make this larger so we can see that somewhere now we have a Christmas tree. Yeah. So I mean, this is not correct answer now because I've kind of destroyed the code. So I mean, this here would have been my correct answer. So the correct answer was 7,753 for my answer. There I found this Christmas tree. But I needed somewhere to, because otherwise, if I just found this, I wanted my code to be somehow generic in some sense. So I needed to find something else that told me within my code that this is actually. So I actually tried to find cycles in the code, and one cycle that I found was that if I kind of, I mean, it's basically a guessing game, but what I did was I was thinking about when all these robots are kind of all in unique positions. So when the distinct count of all the robots' positions will be equal to the total count of all the robots, would that be something I can hang my code up on? So that's what I did. So I actually also, somewhere in this process, I started also taking out the distinct count, and I I showed it, printed it out. Oh. So if we take that out, now we can see this, because the distinct count will be kind of, it will look, it will pendulum around this, but when we had the Christmas tree, that's when it was exactly 500. Again, this might not be the same with your input, so obviously I cannot guarantee this, and that's also, I mean, that kind of emphasize the problem with this solution, but, and the problem with this puzzle anyway. But that's what I found so that's how my code works basically. So when the distinct count of the robot's positions is exactly the same as the total count, which is 500, and that I'm guessing it's the same for everyone. But when they are 500, then it's kind of, it was the right answer for me anyway. So that was a little bit of a deep dive for this part 2, and also some ranting about the problems with it. But I mean, some people probably like this, some people don't. That's always going to be like that. So let's hope we get a good one tomorrow, and I will try to do kind of a live solving of that tomorrow as well. So let's check back, and I hope you do comment, or I hope you, if you like this, hope you subscribe to my channel. So let's see each other tomorrow then. So bye bye.